everyone, today we're going to learn about the pH scale and we're also going to learn about the POH scale. In terms of this lesson builds off our last lesson, so it's very important for you guys to be able to understand what we did in the last lesson. If you're confused, please make sure that you're taking the time coming in and asking questions, and then we can work through it to go on. So let's go ahead and get started. So on these lessons, you're going to notice that I'm going to bold or underline certain things, and these are one of the most important things for you guys to write down. They include things like equations. If they're not bolded or underlined, you are still free and welcome to write them down, but they're not as important. So starting with the pH scale, the molar concentration of H+, which is generally written with brackets, is going to be small. For example, we learned that 1 times 10 to the negative 5 is an acidic solution. And that's actually equal to the number 0.00001. And that's a very small number. This can even get all the way to negative 14, which is quite a few zeros. So instead of writing this long number or in scientific notation, scientists have come up with a unit of measuring acid, neutral, and basic compounds through something called pH. pH is the negative logarithm of the base 10 of the hydrogen concentration. So what we learned last lesson with the hydrogen concentration, we just plug it into this equation. So pH equals negative. We find the log button on your calculator, which you guys learned in Algebra 2. And then you plug in the H plus concentration that they give you, and that will give you your pH. Remember that H plus and H3O plus, or your hydronium, they mean the same thing. We use them interchangeably in this situation. The other scale is called your POH scale. This is where we have molar concentrations of OH negative, and they're also very, very small. So for convenience, we have our POH scale. POH scale is equal to the negative log of your hydroxide concentration. So notice POH is your OH concentration, and then pH is negative log of your H plus concentration. Those are both very, very important equations to write down. But notice they match. So how are the pH and the POH scale related to one another? We learned in the last lesson that the values of H plus concentration multiplied by your hydroxide concentration has to always equal 1.0 times 10 to the negative 14th. This was our equation in the last lesson's homework. Well, because of that, if we take the negative log of 1.0 times 10 to the negative 14th, the highest pH or POH I'm allowed to have is a 14. On the opposite end of that, the lowest pH or POH you're allowed to have is negative log of 0, because if you have nothing, and that's 0. So our pH and POH scales tend to range from 0 to 14. Given that, what is the exact relationship between these two? Well, I'm going to go ahead and star this because this is our fourth equation that is the most important. pH plus my POH is always going to equal 14. So, for example, if I said I had a pool that had a pH of 6, what is my POH? You can take 14 minus 6 and say that my POH is 8. Now that I've kind of talked about what is the pH scale, what is the POH scale, let's talk about it in terms of is it neutral, acidic, or basic? So a neutral solution is one that has hydrogen ions that equal 1.0 times 10 to the negative 7th. This value was one of the multiple choice questions on your last homework assignment, and we wrote it in your notes. That is a value that you guys should know. If I take that H plus concentration and I plug it into our formula, negative log of our 1.0 times 10 to the negative 7th, you're going to find that your pH equals 7. That means if I asked you to find your POH, it is 14 minus 7, so my POH is also equal to 7. So whenever your acid equals your base, that is neutral. What about if it's an acidic pH? Well, what happens to the pH of a solution as we make the solution more and more acidic? Remember, if we're making something acidic, we're increasing our H plus concentration. Because remember, for something to be acidic, your H plus concentration is bigger than your OH. Well, one thing to note is that if your H plus increases, your pH number is actually going to go down. For example, something that's acidic is 1.0 times 10 to the negative 3. If I plug that into my equation, negative log of that number, notice that this number is pretty small on that 0 to 14 scale. So we like to say anything that has a pH less than 7 is going to be acidic. Basic pH is going to be the opposite. If you are a base, generally your OH is going to be bigger than your H plus concentrations. So H plus tends to decrease in a base. Well, these are opposite. If your H plus decreases, your pH is going to be higher. So for example, the last lesson we learned that 1.0 times 10 to the negative 7th negative 9th is considered a base. If I plug that into the negative log equation, I get 9. So you get a big number. Therefore, our pH of our basic solution is always going to be greater than 7. Now, I pulled this little table out of the book that I teach you guys out of, and I think it's a very good summary of what we've gone over. Yesterday, we went over the H plus concentrations and whether it's acidic, neutral, or basic. We learned that anything bigger than 1.0 times 10 to the negative 7th is going to be acidic. That means my OH is going to go down. Neutral, they have to be equal to each other. And then basic. Basic's where I find something that is going to be smaller than 1.0 times 10 to the negative 7th. Notice my hydroxide, it's going to be the opposite. So when I say smaller, another reminder that I want to tell you guys is that you're working with negative numbers. So remember that 1.0 times 10 to the negative third is actually is actually bigger than 1.0 times 10 to the negative 7th. Even though it's a smaller number here, it's actually closer to 0, so this number is considered big. Then over here, it summarizes what we talked about with pH. If it is less than 7, it's acidic. If it's equal to 7, it's neutral. And if it's greater than 7, it's going to be a base. So let's do a couple things. First, we're going to calculate pH from our H plus concentration. So this is going to bring about 2 equations that we've learned. Remember, pH equals the negative log of my H plus concentration. Also, I want you to remember POH is equal to the negative log of your OH concentration. Oops. So if you ever see problems like this, where my concentration equals my value here, you can do a direct, basically, equation. So here I have my H plus, I'm trying to find my pH, so I can use this first equation. And I can plug this in. Negative log of 1.0 times 10 to the negative 12th And you're going to put that in your calculator and see that it equals 12. And you can ask yourself, is this acidic, neutral, or basic? And this would actually be considered basic because this number is bigger than 7. I want you to please note that you always base whether something's acidic, neutral, or basic on your pH value. Down here, same thing. I can plug in negative log of 3.8 times 10 to the negative 4. So negative log of 3.8 times 10 to the negative 4. And you're going to find that you get the answer for pH 3.42 as your pH. When you look at this, since this is less than 7, this is actually considered acidic. The next question people often ask is, does this include, do I need a unit? And the answer is no. Here, you just need to know that pH is equal to 3.42. This is where people tend to have trouble because you have to realize that you need to use multiple equations. So here, if I want to find my pH, but I'm only given my OH concentration, this tells me I have to use 2 equations to get to where I want to. The reason is OH and H are not the same thing. So there are 2 possible ways, and you can pick whichever way works for you. But there are a number of equations that you have to be familiar with. So I'm going to go ahead and write the equations over on the right-hand side. The first equation that you need to remember is your H plus and your OH equals 1.0 times 10 to the negative 7, or negative 4 times 10 to the negative 14th. The other one you need to remember is negative log of your H plus concentration equals your pH. Negative log of your OH is going to equal POH. And then lastly, pH plus POH equals 14. So if you have those 4 written down, you're golden. So the first way to determine our H plus is by dividing 1.0 times 10 to the negative 14th by our OH concentration you are given. So for example, if you're given the OH concentration 2.0 times 10 to the negative third, you can take 1.0 times 10 to the negative 14th divided by your number you're given, and that equals 5.0 times 10 to the negative 12. And this tells me my H plus concentration. I had a few people in class ask, where did you get that from? And where I got that from is H plus equals 2.0 times 10 to the negative 3 equals 1.0 times 10 to the negative 14th. And then in order to get that hydrogen by itself, I divided both sides by my 2.0. So that's what I did here. And this is what I got for my H plus concentration. Then I can take that H plus concentration and plug it into the formula. The negative log of my H plus equals my pH. So when you plug that in, you get 11.3 as your pH concentration. Now, since this is my pH and this is 11, it's bigger than 7, I can say that this is a basic solution. The second possible way is going to be using more of what we learned today. So remember, I did put those equations up on the last slide. The second way to determine it is to find the negative log of my hydroxide and then subtract the number from 14. And my reasoning for that is because of the equation pH plus POH equals 14. So this is what I'm given, OH, and this is my number. I can plug that as negative log of that number will get me POH. So if you solve that, your POH is 2.7. So if I know 14 is going to equal my pH, which I don't know, plus 2.7, which is my POH, you can solve that and do 14 minus 2.7 equals 11.3. Notice you'll get the same answer no matter which way that you go. So you can choose whichever route works best for you. So here I have a couple examples of where we're going to do this. The reason you know that you have to use a two-step, remember, is that I have hydrogen and you're given OH. They don't match. So that tells you need those steps. So just as abundance of caution, if you haven't written them down, please get these equations down somewhere. If you fail to get these down, I have mentioned them enough that it comes down to being on you guys. So pH equals negative log of your H plus. POH equals negative log of your OH. And then pH plus POH equals 0. So what we're going to do is we're going to do the left one, we're going to solve one way, and the right one, we're going to solve the other way. So here on the left-hand side, we're going to solve the first way to kind of show you that one again. So we can say, oh, this is my OH concentration. So I can say, okay, H plus times my OH, which is 1.0 times 10 to the negative 11th, has to always equal 1.0 times 10 to the negative 14th. And you can solve this by dividing by 1.0 times 10 to the negative 11th. And that tells me that my H plus concentration is actually equal to 1.0 times 10 to the negative 3. So now I have my H plus concentration. I can actually go ahead and use my pH equation to solve for pH. So here I can take my pH equals my negative log of my 1.0 times 10 to the negative third. And when you plug that in, you will find that your pH equals 3. So here, based on my pH value, I can say that this is acidic. Over here, we're going to solve step number 2, or the second way over here, to show you that one. So first thing, remember, this is an OH concentration. So I can actually use POH. So I can say POH is equal to the negative log, and I can plug in my OH concentration. And when you do that, we are going to find that POH equals the negative log of 2.1 times 10 to the negative fifth, and you're going to find it to be 4.6777800705. But I want to find the pH. So if I know that pH plus POH equals 14, sorry, please correct that, then I can solve this by taking 14 minus 4.6777800705 to get my pH. So pH is going to equal, once you subtract those, approximately 9.3. So here, if I look at this number is bigger than 7, so I can say that this is a basic solution. So again, we're going to tie this out. That's the end of the lesson. If you have not written down these things, you need them. If you struggle or have any questions with the homework, please bring it up and we can walk through some example problems if you'd like to. And otherwise I hope you guys have a good day.